Hello everyone, I am Praveen. Today I am going to explain the implementation of recursive and non-recursive algorithms using Fibonacci and factorial programs. First, I will explain recursion. Recursion means a function calling itself. It is used to solve a big problem by breaking it into smaller subproblems. Recursion must have two parts. The first part is base case. It is the stopping condition. The second part is recursive case. It is where the function call itself again. One common example of recursion is factorial. Next, non-recursive method is also called iterative method. It uses loops like for loop or while loop. It does not call itself. It repeats the process using loops until the condition becomes false. One example is factorial using for loop. Now, I will explain the time complexity. Time complexity tells how much time a program takes to execute. In factorial, recursive method time complexity is order of n. Non-recursive method time complexity is also order of n because both run n times. In Fibonacci, recursive method time complexity is order of 2 power n. It is very slow because it calls the function many times. Non-recursive Fibonacci time complexity is order of n. It is faster and more efficient. Now I will explain Fibonacci series. Fibonacci series is a sequence like 0, 1, 1, 2, 3, 5, 8 and so on. Each number is the sum of the previous two numbers. The formula is f of n equals f of n minus 1 plus f of n minus 2. For example, when n is 6, fib of 6 equals fib of 5 plus fib of 4. This continues until it reaches base case 0 and 1. The output is 8. This is the recursive Fibonacci program. In this program, the function call itself. If n is 0, it returns 0. If n is 1, it returns 1. Otherwise, it returns fib of n minus 1 plus fib of n minus 2. This continues until base condition is reached. This is the non-recursive Fibonacci program. This program uses a for loop. It calculates Fibonacci numbers using variables. It does not call itself. This method is faster and more efficient than recursion. Now I will explain factorial. Factorial means multiplying a number with all smaller numbers until 1. For example, 5 factorial equals 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. The result is 120. This is the recursive factorial program. In this program, the function calls itself. If n is 0 or 1, it returns 1. Otherwise, it returns n multiplied by factorial of n minus 1. This continues until it reaches base case. This is the non-recursive factorial program. This program uses a for loop. The loop multiplies numbers from 1 to n. Finally, it prints the factorial result. Finally, I will explain applications. Applications of recursion include tree traversal, graph algorithms, Tower of Hanoi, and divide and conquer algorithms like merge sort and quicksort. Applications of non-recursive method include simple calculations, large input problems, memory efficient programs, and real-time systems. Thank you to all.